Hey guys, welcome back to Tech Talks. This is AK. So in previous video we created add to head method and we added nodes to the head of our linked list. Okay, so now we are going to create our head to tail method and it's going to be very similar to our head to add method, just the reverse. So this is the head to add method. If you want to understand it better, please watch previous video and you can find link from the description box below. So let's start creating new method which is add to tail. So we will say linked list dot prototype dot add to tail equals function. Now we will pass our value parameter like we passed in add to head method, because we will use this value parameter to create the node that we are going to add to the tail. So we will say variable new node equals new node, and we will pass in the same value parameter that we passed into our method right itself here, this value parameter. So we will pass this value parameter here. So we say value. Since we know that this node will be added to the tail, we know that there will not be a next node in this linked list. So we will pass null as the next parameter for our node, and we will pass current tail node or this dot tail as the previous parameter. So we pass this dot tail. Okay, so the next step is to account for whether the linked list is empty or not. So we will say if the linked list is not empty, or if this dot tail means if linked list has tail, it will not be empty. Then we set its next pointer equal to new node. So this dot tail dot next is equal to new node, which will soon be the new tail node of our linked list. So we say this dot tail dot next is equal to new node. Then we say if the linked list is empty or simply else, then we will want to set our head pointer equal to our new node, because this will be the only node in the list and it will be both head and tail node. So we will say this dot head is equal to new node, and finally we will say this dot tail is equal to new node. Because we are adding at the tail, whatever conditions it fulfill here, the new node is going to be tail node as well. Great, this is our add to tail method. As you can see, it's just the opposite of our head to add method. Cool. Okay, let's start with the blank linked list and add some nodes to the tail of it. So we will say where my linked list is equal to new linked list, and we will start adding a node to the linked list. So I'll say my ll dot add to tail, and let's pass value say 10, and this will be our first node of the linked list. Now let's log out our linked list to make sure it's working correctly. So I'll say console.log my ll and run this code. As you can see here, our head and tail both are same node, which is we just added here with the value 10. So you can see head is the node with the value 10 and tail is the node with the value 10. This is our first node of the linked list, so this node is both head and tail. Great, that is just what we expected. Let's add a couple more nodes to the tail. So let's say my ll add to tail, let's add 20. My ll add to tail, let's add 30. If we console log out linked list, now head of our linked list should be 10 and tail of our linked list should be 30. So let's run it. Yes, so head of our linked list is the node with the value 10 and tail is the node with the value 30 we just added here. Now to check and make sure that our method is working correctly, we will traverse through the linked list node by node and log it out to the console. So let's say myll.tail.preview. When I run this, so it will go to my linked list, then tail which is 30 and previous which is 20. So it should print node with the value 20. Great, we get exactly what we expected. We just logged out our node with the value 20 here. Now let's log out my linked list dot tail dot previous. So it should log out 10 on the console. Great. So it is logging out node with the value 10. Perfect. So what if we use our both method, head to tail and head to add method? Will they work properly? Will they work together? Will they work together properly? Let's see. So under here, let's add one more node to my linked list, which is add to head, and let's say 100. So now our head of linked list should be node with the value 100 and tail should be the node with the value 30. So if I log out only my linked list, so it should have head node with the value 100 and tail node with the value 30. So let's run it. Yes, perfect. So our head node is the node with the value 100 and our tail node is the node with the value 30. Great. So the head property is pointing exactly to the node we just added with the value 100, and the tail is pointing to the last node added by this method head to tail, which was 30, which is good, meaning they have correct reference to each other. Great. So as a final example, let's console log out my linked list dot tail dot previous dot previous dot previous. We should be logging out the node that we just added now, means head node. So when we run it, it should print 100. Yes, great, it does. It printed the node with the value 100 and next property with the value 10 and previous property null because it was the head node added by this method just now. So it looks like both of our methods are working as just expected. In the next video, we will write methods to remove node from the head of the linked list and removing node from the tail of the linked list. So see you in the next video. Please write down all your questions, suggestions and feedback in the comment box below. Like this video if you find this useful and share with your friends who might find it useful for them as well. And don't forget to subscribe to get notified about more technical interesting videos from Tech Talks with AK. Thank you.